Hello there, everybody. It's January 7th, 2015, and this is a Playscii dev update. As you can see, I've made some progress. I started programming Playscii over the Christmas holiday while I was at my parents' place. Brought my laptop along, and you might have seen some of the vines and stuff that I've done, just showing like weird little progress things. But yeah, this thing that's on the screen right in front of me right now sort of shows off the progress that I've made. Which I'm not sure if it looks like much or not, but it kind of serves as a proof of concept for for just, yeah, like a lot of the general things in the application. So let's get into it. So yeah, what this is doing here is we're seeing multiple frames of animation, and also multiple layers for each of those frames. And I've got the camera kind of tilted here so that you can tell that things are moving in different levels of parallax. We've got like a base layer with opaque black behind it, and then there's characters, the characters on that are changing. And then on a layer above that, I've got some Playscii characters here, like the little rounded thing with different colors, and then I'm animating those colors over the course of 7 different frames of animations. And then we've got a little emoticon up on the third layer here that's just kind of flipping back and forth between these two things. So yeah, it was quite an adventure to get to this point. So yeah, maybe I will open up the code here and talk a little bit about what that required. So there's two different concepts here being represented visually. There's the actual art, which is comprised of frames, which are frames of animation, each of which are comprised of one or more layers, each of which are comprised of as many tiles as the images. And this is an 8x8 tile or character, whatever you want to call it, image, and within those 8 tiles, we've got 3 different layers that are each at different z depths. That's why they're rendering with this kind of parallax thing in a perspective view. And then each of those tiles can have a foreground color and a background color. The tiles on the black layer here, on the layer here that's black, all have a background color set for black. All the other ones, everything up on these higher layers here, has its background color set to transparent. So yeah, that's and if you've seen me do ASCII stuff before, you know that like the basic unit of like a tile has a character, a foreground color, and a background color. This is the letter E. It's got a black background, and the foreground color is white. So yeah, so art is really just kind of like a list of, or like a grid, if you will, of all of these things. And yeah, so part of my goal with Playscii here is to get my first big usable milestone will be to get back to the point where basically attain feature parity with ASCII for all of the basic editing stuff, so that you can actually create these art things, but also add frames of animation and layers, like I've done here. The actual editing interface isn't done yet. There's actually no user interface to speak of aside from just these debug keys that I have to drive the camera around and cycle through frames of animation and pause and play back, pause and play the animation sequence. Which means that and so there's all this stuff that an art does to set its state correctly, and some stuff that I'll get into in a bit when it needs to turn into renderable geometry. And this test art that you're seeing here is actually like, this is just sort of some test stuff at the bottom, where I'm actually setting all of these character values manually. Before the program has an interface, I'm kind of keying these things in tile by tile, and I'm saying, okay, at this character here, get its index and then set it here, which is obviously, and then even more torturously to do the color animation where it's like moving around here, it's like, I'm just manually shifting those colors around. So obviously that's a big pain, and wouldn't it be great if the whole point of this program was to be a GUI so that you can do things like that? So that's exactly what I'm going to do. But first I needed to kind of get, there's kind of a chicken egg thing there where you're like, well, I want to make a paint program, but first it has to even just be able to display pixel images before I can start editing those pixels. It's the same thing. It's the same kind of thing here. And so yeah, all this manually created nonsense here, is just sort of so that I could get to this point and be sure that layers and frames of animation were indeed working. And yeah, you can get up close and see the frames change and yada yada, and it's great and it works. So yeah, this art isn't just this art class. I'm not the kind of programmer who has like a big object-oriented hierarchy or anything. So this art class is really just kind of, it covers a lot of this stuff here. And originally, I had been thinking that art was just sort of a class that represents the stuff that gets written to disk, specifically the tile data for each layer of each frame. And then as sort of an afterthought, or like as, and then the other key class in the mix here, I'll open that up, is the renderable. And this is actually the OpenGL object that gets, displayed, manipulated by the GPU, and it's drawing this, via shaders and all that kind of stuff. And one thing I realized pretty early on was that, like a renderable, like a specific instance of an object. Sorry, I should back up. Ultimately, it's my goal to be able to have not just this one object that you're working on, like for an art document, but ultimately my goal for this is to make this a game engine sort of thing, where you can have multiple objects, each of which have their own art, kind of like objects in Game Maker or something have their own sprites, and those things are moving around the screen and they're playing animations and doing all that kind of stuff. And so it doesn't make sense to have all of the unique data for art in the renderable stuff, because the renderable is really just the ultimately it's kind of a wrapper for an OpenGL vertex array object. The thing that actually down in the render function here, gets shipped off to the GPU for rendering. So a renderable is kind of a renderable instance of an art. If that makes sense. And so then what I realized was that the art probably shouldn't just contain the characters, like the character and the tile data and the layers and all that kind of stuff. It probably also should help translate its data into stuff that renderables can use, and particularly if we're going to have multiple renderables flying around, all of which could use the same art. If you have multiple objects that use the same, if you do a little Mario sprite out of Playscii characters and it has animations, and you want to have multiple ones of those running around, yeah. So what I realized was that that there actually needs to be some code in art that is responsible for creating the arrays that renderables turn into buffer objects. That renderables submit to their buffers, which then get used, which then get sent to the GPU and used by shaders and such. And my first implementation of this that I had about 5 days ago or so, just after the new year, was it was actually it was a lot more clunky, and it was about twice as much code because it used this intermediate format. It used a Python list of lists, like as I had done on ASCII, as kind of an intermediate format that was then turned into these arrays for character data and all that kind of stuff. And what I realized was that was completely unnecessary, and actually the logic for keeping the renderable array data in sync with the internal representation was a ton of it made the logic more confusing and all that kind of stuff. So now the art actually just keeps its own. Some of this stuff is difficult to visualize, so sorry if the visuals aren't amazing and awesome right now. So basically, this one piece of art keeps all of the vertices, UVs, and then the color and character arrays and stuff for each frame of its animation. Yeah, and then there's like get and set methods, and when these arrays are initialized, they're just kind of done in big batches, like they're NumPy arrays. So they're using yeah, like up here, like when we add a layer, for instance, here's the code that does that. It says, okay, give me a new NumPy array full of zeros, and then yeah, that's the other thing, like to be able to render on screen in one draw call, all the layers, all the data for all layers is in one array, and just so that like if each layer were an object, were its own vertex area object, then that would get kind of cumbersome to keep them all in sync and all that kind of stuff. So it really did make sense to do things this way. But it involves kind of like juggling, or not juggling really, but just like kind of getting all of these types of data in a row, and so forth. The one thing that I haven't, my next step here, once I've got, and actually, but before I get to reading and writing from disk, let me jump over to the to the shaders, because actually that's where a decent amount of this stuff is happening. So yeah, this is the Vertex Shader, and what it's doing here is it's taking those arrays of data. So like, let's see here. Let's open up. I'm going to open up just because it probably makes things make a lot more sense here. This is the character set texture. And this... And this is the palette. So yeah, everything that... This is Playscii's memory video texture memory footprint, rather, I should say. This is just a texture that has the Playscii character, the PetScii character set unpacked onto it, and then this is just an arbitrarily sized image with different colors in it. And so okay, yeah, we're backing up even further here. What it does with the palette is very simple, really. It just goes through this image, no matter what format it's in, if it's indexed color or not. It ignores palette data because, see, that's an architectural decision. I decided that having used the actual source images palette for ASCII 2.5 years ago, I realized that like there aren't really like very good tools for manipulating indexed color or palletized image data, and that it's actually much easier to just open up something, a new image in MS Paint or whatever, and then just create a swatch that is nothing but the colors that you want to use for the palette. And so it just kind of goes through and it analyzes the image. It goes through pixel by pixel on initialization and looks for all the unique colors, and then adds them to, and then generates a texture that the shader then looks up. So it takes this source image here, and it ends up looking very similar to this because it's all the colors in a row in the order that they were discovered, and then creates a new texture that is fed to the shader. So yeah, and then it also, like, just to make things a little easier for doing defaults and stuff, it actually it looks for the lightest and darkest color, so that if we ever need to draw a text or something in a debug capacity, we know that we can do light on dark text or something like that. So that's the palette. The character set is a little more complex because we're going through this image, and in addition to just turning it, we turn it into an OpenGL texture, but then we also kind of analyze it, and in addition to, like, there's this metadata that goes along with it. And so this is just a plain text file that spells out with string characters what these things map to. And even that isn't like, I don't know, I'm trying to decide what the level of detail I should go into here should be. So for now it's like, the character set gets mapped to various things. all of these things end up being, all of the characters on this texture sheet end up being indices. So this is index 0, this is index 8, this is index 16, and so on, because this thing is 8 by 8. Well, it's 128 by 128, and so, you know, 8 by however many characters, you know, because the Commodore thing, the Commodore PETSCII set doesn't fill up the whole thing. And so, you know, like index 142, for instance, I think is this character right here. So yeah, like everything in an art, like anytime that we set a character index, we're actually just setting these indices in an array. And then that character index ends up making it to the Vertex Shader as a float, because feeding integer attributes into a GLSL shader is apparently a bad idea that produces unpredictable behavior, at least with the tech that I'm using, like PyOpenGL and so forth. So anyway, yeah, it takes character index, and then it kind of like, and then it's like, okay, I'm going to translate that into, I have this index like 142 or something, and then I need to turn that into X and Y offs. I need to turn that into UV coordinates that will help me paint the right character onto the correct quad. One question you might have is, why am I doing this math in the shader rather than just pre-calculating the UV coordinates? And one answer is just that this math is actually very simple. Like, this is not, it uses one float modulo operation, and then it uses a floor. So like these two lines of code that I've got selected right here are all it takes to determine, well, actually, yeah, and then once you translate it, you know, from tile map space into UV, once you translate it from tile numbers into UV numbers, I guess it's 3 lines of code. But yeah, so like there's very little math, and the reason that I ended up doing this was in the first pass, I did have, back in art, I did have these lists that just had the indices, and then I would like translate those every time, and that's what ended up being more cumbersome. That's what made me, you know, I didn't do this because it was, you know, for like an abstract reason. It was actually a very concrete reason, because this code got really hard to think about, and there really was, I swear, like twice as much of it when I was like having to like manually update these arrays that were actually what the shader dealt with. And that's really all the Vertex Shader does. Like, it determines the thing's position, you know, so like the fact that we're seeing this view in perspective and that we have a camera we can move around, that's all happening in the first line of code here, because it's taking you know, the camera made a camera matrix and a projection matrix and so forth, and then, you know, like just determining the vertex positions, and then it's going in and saying like, okay, so for any given vertex in this like grid of quads, what UV should I use to get the right coordinates from the character the character set texture sheet, which is this thing, and apply those, and then pass through, like there's 2 other indices that will determine the foreground and background color of the character, and that actually gets used in the pixel shader, so just pass that on through to the pixel shader. By the way, if anybody knows, like, it always feels kind of weird, like when I kind of understand why it has to work this way, but like it feels kind of weird like passing these color indices into the vertex shader when when like they're really only just passed into the pixel shader here, the fragment program. And I think I understand why that has to happen, but like, I don't know, you know, I could just get rid of this and get rid of this if, you know, if there was another way to do that. But anyway, it's not really a big deal. And so then back in the things get passed on to the pixel shader. And it says, okay, so we've got 2 textures that we're dealing with here. We've got our character set texture, and we've got our palette texture. And we kind of need to know, because of the weird little lookup thing we do to get the color from the palette, we actually need to know the width of this texture, and I think you can get the width or the dimensions of a texture from within GLSL, but it's a relatively new, like OpenGL 4 specific feature, so I didn't, I didn't bother with, I don't want to do anything risky compatibility wise. And it's just one uniform number to pass in. So anyway, we get the texture coordinates from the Vertex Shader, and then we look up this, and it says very simply, like, okay, well, what pixel from the character set texture should we grab? Oh, it's this pixel, cool. Okay, so now we've got that pixel. And then it looks at, it says, okay, what's our foreground color index, which is going to be like 0, 1, 2, 3, 4, 5, 6, 7, And now turn this into the UV coordinates for the texture that we generated for this palette thing, with one pixel being, with each pixel being a unique color in the palette. And so then we have our foreground color. We actually have our foreground color as an RGBA, 4-component classic color that we can do stuff with in GLSL. And so make the take the thing that you grabbed here and turn every pixel in that thing, every pixel of its RGB, leaving its alpha intact, turn every pixel of its RGB into the foreground color. So when we look at this little piece right here, what it's doing is it's saying, okay, well, this this top right corner elbow, like rounded elbow piece, like this is the character index, and this is the bit from that we're drawing onto this quad. And then we're like at index 5 here, and so draw that, like make all of its colors, make all of its opaque pixels into that purple color. And then it applies the background color. It says, okay, what's our background color? Get that from the palette texture, and then go in and say any pixel that is perfectly transparent, i.e., like the pixel that we got from our character set texture here, if it's fully transparent, then actually change that pixel entirely into the background color. And this gives us exactly the effect that we see here. So that's what's going on in the shader. And it's relatively little work, compared to like big fancy shaders that do normal mapped walls and all that good stuff. So this feels relatively efficient. There's probably a bunch of ways I could make it better, and I'll do that, in time as I learn more or as people give me good advice on stuff, whatever. So anyway, that is how, and it starts off with just these indices, which are very easy to represent. It's like a very small amount of data, and, we're only having to change a small amount of data each time we make an edit to this image, etc. So that all kind of works. The next step that I have actually is some code that I had working before I rewrote it, before I did the rewrite that was much better. And that's actually, so the next step here is being able to, right now, it generates all of this stuff at runtime. Like this isn't loaded off of disk, except that it's the code that actually changes all of these things. And obviously, for this to be a usable art creation program, it needs to be able to save files to disk and then load data from disk, and in the future, hot reload data from disk when it changes elsewhere in the program and all that kind of stuff. So that's my next step. I'm going to go through, and this is like an older version. Yeah, this is tentatively what a Playscii native format file is going to look like. It uses the JSON syntax. JSON isn't really a file format. It's more just like a syntax for representing data, and in this case it corresponds pretty nicely with Python's own system for representing strings and dictionaries and lists. So yeah, and I don't actually know, one thing I need to, like, I don't know, so like this stuff, sorry, I'm jumping around too much here. Yeah, like a given file is going to save some things about it, like its dimensions and the palette with which it was created, and then it's going to save like a list of its frames and then what the value for each layer in each frame is and all that kind of stuff. And then each tile is really just a background color, a foreground color, and a character. And these are all just indices, right? Because they're like, index 0 is the top left corner in the character sheet, and yeah, so all these values ultimately end up doing what they do in the Vertex and Pixel shader. So anyway, getting this kind of data saving to and loading from disk is my next step, because that will turn the program into something that actually starts to feel like an editor, where you are changing data and then you're saving it and refining it and all that kind of stuff. And I think I need to get that stuff saving. I think I need to get things loading and saving before I do the edit tools. Although, I mean, honestly, yeah, I could. This is the looking ahead portion. I think I would like to get file loading and saving working, and then I'll start doing UI. And the UI will be something like, well, I'm moving my mouse over this, and I see like a cursor highlighting the tile that I'm working on. And and then I can click on this and change it to something, or I can, in ASCII you can hit spacebar to pull up the panel of characters and stuff. So just doing that whole like editing the whole document in front of you. But I think that's actually going to be a lot of work, so I might as well just get the ability to load and save things from disk, because that will save me from having to have code like this, which this is all the junk that generates the example art that we're seeing now. So I think that's my order of operations. It's a pretty clear path ahead. I had some real difficulties like wrestling with, oh yeah, why aren't integer attributes working? Like I was stuck on that for like a good day or two, and that was frustrating, but I'm pretty unblocked now. I'm sure I'll run into some other issues down the road, but all of the decisions that I've made so far seem to be panning out pretty well. Obviously, I'm not in a position where I can test performance yet. I mean, I guess I could just make a really gigantic... Yeah, actually, let me do something right now. Like, I've got a little config file here. Why don't we launch the program and tell it to just be changing stuff here? Yeah, so I guess one thing I could do to test performance here is make a really big document, make a really big grid of tiles, and then just run this randomly. All this is doing, this mutate function is really just changing a random tile to a random color, character, and foreground and background color each frame. And yeah, it only does that for a single frame, I guess. So yeah. Like they always say in programming that premature optimization is the root of all evil. And in this case, like, I have done a bit of thinking, like, I guess there's a world in which I could, just implement this whole big mess and try it out, implement it in the most straightforward way possible, the way that comes to me, and then try it out, and then start trying to do more ambitious things with it, like have more objects on screen or have bigger documents or something, and then run into performance problems, and then think about how to optimize it. But I guess just using like my experience as a programmer and just the thinking that I had done about how to represent these things, I think, what I'm doing here is probably not premature optimization. It's probably just figuring out a good way to represent all of this in a way that I'm not just going to have to completely rewrite later on if I run into performance problems. Now, I mean, I'm kind of staking my a bit of my programmer ego in that. But I think I've learned enough about... I think I've learned the right things. I've had good advice from people in the know and stuff. Yeah, so I think this is going to work. And if not, hopefully I'll have an easy way to optimize it later. And it did definitely help me understand the problem better. I learned a fair amount about OpenGL and NumPy and just all that kind of stuff. And so yeah. So let me go back to a nice visual here. Yeah, so I think that's all I've got for now. But yeah, it's exciting. I've been making pretty good progress you know, factoring in that sometimes you get stuck and you're not going as fast and you're a little demoralized. But yeah, now I've got a nice pretty thing that I can start turning into a real application that you can edit stuff with. So hopefully next dev update that I do will have some of that. So thank you so much for watching, and Patreon supporters, thank you so much for your support. You really are like the reason that I'm able to keep doing this, and that, you know, I'll be able to keep doing this a month from now or something. It's going to be a long, hard road, but you know, I've got hope, and I've got some awesome folks who are helping support me, and you know, you're awesome for looking at this, no matter who you are. So yeah, thanks very much for watching, and hopefully next time we'll have a whole bunch of cool new stuff. So I think that's it. All right. Good night. Oh, and one more thing. This wallpaper here, in case you were wondering, this is like a glitched, like a bad keyframe from an episode of Babylon 5, I guess. So that's your end of dev stream trivia. Okay. Good night.